Well, thank you so much, and thank you so much for coming. I'm going to cover today our work in one area of social media mining. I have funding from the NIH to do this for about 7 years now. So we decided to zoom in into birth defects using Twitter data. We've seen already 2 presentations on pregnancy, so that saves me a little bit of time in motivation. But particularly to birth defects, this is the leading cause of infant mortality in the US and the world. The etiology of these birth defects is often unknown. It's very hard to tell what happened. It fills the mother with guilt, with a sense of, did I do something to cause this to my baby? So it is mentally is a very, very heavy burden to carry, and physically and economically as well. The methods for observing pregnancies with birth defects are very, very limited. In theory, you could have clinical trials, animal models, or registries. Clinical trials are actually out because no pregnant women are allowed or included in any clinical trial. So that's out for any new medication, actually. There is no proof whether it's safe in pregnancy or not. All the knowledge about the safety of drugs comes from borrowed models, basically. So if it's safe or relatively safe in animal models, then it is okay and people are observing. So pharmaceutical companies observe and track through these registries. It has many limitations, though. Animal models have limitations. Not all of the things translate well to humans. And registries have many limitations, particularly bias. So women cannot often remember all the things that they're asking them because they are not in the registry usually until after a birth defect happens. With new medications, the doctor will say, "Oh, go register in the registry," but really, not too many women do. It could be, it has all kinds of psychological reasons behind it. Mostly something like nothing bad will happen to me. And if I do something, it means I feel that something bad is going to happen to me. And if I think something bad is going to happen to my baby, then something bad is going to happen to my baby. Kind of like that. The mind of a pregnant mother is very complicated, I tell you. I have several of my own, so. Motivation. So we are looking at ways to supplement this lack of information. We looked at social media. I've been working on it for 5 years, and we looked at social media at that point for pregnancy. It has been questioned on who uses social media, but we happen to have the demographic that hits smack in the most popular users of social media. So the age bracket that we're aiming at is that has the highest use of social media. But really the question right now is who doesn't use social media? Is really so prevalent. 79% of all adults in the United States use some sort of social media. Worldwide, that's about 45%. And then we look into it now time, and that's like how long do they use it? So 3 hours is the average daily of use of social media. So that generates, if you multiply times all these millions of people, it's just mind-blowing. All the data that's out there. How to use it is the trick. So our central question is, can social media data fill the gap that we have, particularly in pregnancy? More specifically, can it be used as a complementary resource for observational studies of birth defects? And you can substitute birth defects with any other outcome in pregnancy that you would like to observe. It's the same question. We're exploring all of them. And our methods in NLP have advanced to the point where we can do this. So given the time, I'm going to try to give you a quick overview of what we have done. But basically, Twitter data has pros and cons as everything for this kind of observational studies. The large volume I mentioned, the tweets are publicly available. Okay, so there's a whole IRB ethics discussion. I wrote a blog myself, so if you're interested in it, I'll tweet about it afterwards. Just we treat it as public when it's public. If you tweet publicly, that's publicly available data, and we use it for observational studies. There are some details like about contacting, not contacting, and so on. All that has a whole other track on this probably. So this was done under IRB, is actually excluded in the United States. We have this exclusion from IRB full approval, which basically means it's publicly available data, you can use it. So it was done under that. Another problem is the user timeline. So we have sort of a biography, publicly available biography of what's going on. So right now, people know I'm in Switzerland at the Applied Machine Learning Days conference because I've been tweeting about it. So in essence, you can follow sort of one aspect of my life through Twitter. Myself, I tweet in a certain style. Other people tweet in other styles. Data is there. So that's a great advantage, and it's exclusive to this type of data: Twitter, Facebook, Instagram, web forums, health forums, and Reddit fall under other categories. And depending on the popularity in different countries, you could use them in different ways. It is still a very unstructured free text, very, very noisy, very informal in language, many holes in the data. But which data is perfect? If we were to require perfect data for any study, we will never be studying anything, actually. So we use the data as it is, and we try to adapt our methods to the weaknesses of the data or the limitations of the data source. And we have shown through many publications over the years that it is possible to do very systematic epidemiological studies with social media data. So what we have accomplished from just the time frame of the last 3 years. We collected a cohort of about 500,000 pregnant women. This is self-declared pregnancies on Twitter. Not assumed, self-declared. So we're having a baby. Okay, we capture that. And now we can go from there and observe this timeline of this user. I'm 20 weeks pregnant to date, or so on. So there's many different ways to capture a pregnancy announcement, and we have done that. We have grown our collection over the years. Towards the end, we did use Twitter data for case control study of birth defects, and we have shown that it can scale. So we did it at a very time-intensive, very expensive annotation effort. It's not Mechanical Turk. We did it in-house. 2 experts annotating full timelines, about 500 hours of work to annotate 400 timelines. Actually more, it's 2 hours per timeline. So we have case controls, so cases were 196, controls were about the same, 2 hours per timeline, about 800 hours of work. What we accomplish, or what we want to accomplish, is complete this whole timeline for processing. So we start with the Twitter collection. We move to trying to determine the pregnancy time frame in that timeline so that we can see events that happen during pregnancy and distinguish that to pre-pregnancy and postpartum. So we can do that. We have also looked at how medications are mentioned in that timeline. For those of you in NLP, it's a very, very sparse data. 0.3% of the whole timeline has a medication mentioned. So these things are hard to find. It's different than doing a keyword-based search of things. Keyword gets you about 70% of them, but it being already a very, very small sparse set, it becomes complicated. Determining the prenatal period is also tricky. We need to extrapolate from the different kinds of announcements, the beginning of pregnancy, the expected end of pregnancy or term. And so we work in all that. There's papers. I don't know if the slides are going to be made available, but okay, perfect. So I have papers cited in each of these slides. Finding the birth defects cases presented other challenges. Is regular expressions at its core, but it presents problems in terms of the language. Many times birth defects are mentioned, and that doesn't necessarily mean that that baby has the birth defect, or that that person tweeting is the mother of that baby, and so on. So there's many nuances in language that we're able to clear up with some of the machine learning approaches that we have. Medication mentions, same thing. We have lexical approach, and then we grew that into using deep neural networks to find the medication mentions. This covers things like I just took my seizure medication. Okay, so even if we don't have the name of the drug, this is informative in and of itself. So finding those different expressions that will indicate a medication is tricky. So we have finding medications in very unbalanced data sets. Setting up a Twitter nested case control study is tricky. Believe it or not, finding cases is relatively easy. Finding the birth defects themselves is relatively easy, even what I said before. Finding a term pregnancy with normal birth weight, a little bit more complicated. We can get lucky sometimes, and we have a birth announcement that has both. But many times it's not the case. It's like baby is born, everything's fine, and then so now you have to really check term and birth weight. And so we did something like that. At the beginning, we have a very small control group, but we completed the study. We included medication intake, ethnicity, sex, and country compared to the control group. And what did find one significant finding is medication intake in the cases was significantly more, significantly greater among the cases than the controls. So not enough cases, though. There's some limitations, and actually not enough controls. So we want that 1-to-4 ratio of cases to controls to really call it a day. But with that cost of annotating, it makes it very, very hard. We're close, though. We have grown it, and now we have come up with a semi-automatic way of detecting more likely controls. So it's dual tweet expression finding task, where we find the term and we find the weight, and then we use AI or rules basically to try to determine when both conditions apply to the same pregnancy, and that becomes a better control than what we had before. Before we had a sort of a negation. In the absence of information about a birth defect, we assume it's a normal pregnancy, which is not very clean. We're going to rerun our findings. They are published anyway with the other one. So we're going to rerun the same study with a cleaner control group and see if our findings stands. So we aim to have all our studies be reproducible. This is the latest. This was published in Nature Digital Health or Digital Medicine. Nature Digital Medicine. We have now deployed these techniques to find new cases in our larger data set. We ran the initial one in a small 120,000 timelines. Now we have 500,000, so we can get more cases. So that's in summary what we have done over the last 3 years under funding by the NLM. It's an R01, so you're familiar with the funding mechanisms. It covers 4 or 5 years of funding and is the second cycle. So I'm in year 7 or 8 of this research. Contact at UPenn and Twitter at Graciela Gon if you want to connect. That's, I think, the easiest way because it seems like our coffee break is going to be crowded with questions. And I can take, I think, 1 or 2 questions. One question, if it's long or short. Yes?
How representative do you think the Twitter population is of the general population? Because recently in political science, what people are finding out more and more is that Twitter population is a very specific subset of humanity.
Yes, in this case, we're already focusing on women that are on pregnancy age. So is the demographic matches. Mind you, if you're talking about different education status and so on, there are some studies on that. It seems like Twitter of all platforms will give us the greatest reach. And as any epidemiological studies, when you select your study group, you're going to have some biases and limitations. As long as you recognize them, I think the study you can run studies still. Out of this group, since this is the one that most uses social media, I think if anything, if you want to study women's health and pregnancy in particular, this is a great platform. It doesn't suffer from many of the biases that you will expect for other things. All right, thank you.